Well, let's go ahead and introduce our panelists. We have got Dylan Kennedy. Dylan is the Global VP at AMQIO, and he's going to be talking to us a little bit about their work with the MQTT protocol. We also have Ayanda Dube, who is an engineer at 8x8. He's also a RabbitMQ contributor. He's worked with Erlang Solutions in the RabbitMQ division as the RabbitMQ lead engineer. So he is ostensibly our RabbitMQ or our AMQP expert. And we've also got Pawel Chrzaszcz, whose last name I did my very best to pronounce. I'm sure he could correct us in a moment. Paweł is a team lead and architect of MongooseIM at Erlang Solutions. Welcome, everybody. Thank you so much for being here. So I've got some questions, plenty of questions, honestly, for each of you. But what I'd love to do first is just give each of you guys an opportunity to tell us a little bit about your work in these respective areas with these messaging protocols. What technologies are you working with today? How do these protocols fit into them? And what's exciting about the work that you're doing with them? But before that, I like to try to kick these off with something of an icebreaker, just to sort of loosen up our panelists and our attendees. And I wanted to keep it messaging themed. So you have to pick a messaging protocol. You have to tell us if you prefer message in a bottle, a carrier pigeon, or smoke signals. Messaging protocol of choice. And I'm just going to pass it down the list of who I see here. So Paweł, tell us your messaging protocol of choice, and then tell us a little bit about what you're working on now.
Do you mean these three, like the protocols that you just mentioned, right?
Yes, so of the three that I just mentioned.
It would be pigeons. Because they already proved to be more efficient than some internet service provider in Africa, as far as I know. It's true story. And there is also like this funny protocol that you can about sending actually network traffic via pigeons. So yeah, and there's a lot of pigeons in Krakow where we are based.
Excellent points all around. I'm curious to learn more about the carrier pigeon messaging protocol, but perhaps that's a topic for another day. Yeah. So Paweł, go ahead and tell us a little bit about the product that you're working on. What's special about it? What does it have to do with any of these messaging protocols that we're here to talk about today?
Yes, so the product is called MongooseIM, and IM stands for instant messaging. And the protocol that we are using is XMPP. Extensible Messaging and Presence Protocol. And the typical use case of this protocol is any kind of messages sent between some end user devices usually. And nowadays, these are mostly mobile devices. So the server needs to handle a lot of clients that are connecting and disconnecting all the time and sending messages. There is no like predefined pattern, and sometimes you get like sudden waves of messages and bursts of traffic, and the server needs to handle that. So MongooseIM is that kind of messaging server that can handle large scale. By large scale, I mean, for example, millions of clients connected at a given time.
Excellent. Thank you for sharing that. I've already have several questions for you based on just that one little synopsis that you shared, but I'll give our other panelists a chance to introduce themselves before we dig in. So moving along my little Zoom screen, we have got Dylan up next. So Dylan, if you would please tell us, would you prefer message in a bottle, carrier pigeon, or smoke signals? And then tell us a little bit about what you're working on these days.
Yeah, I mean, and that's a great icebreaker. I'm very pleased to have it put a smile on my face. What Paweł said there, and I think he chose the best one personally out of the three. I think with a pigeon, you can nearly guarantee that it's always going to get there. I actually was going to go for a message in a bottle, only because of the bottle thing, more so than anything else. So my icebreaker back to you is I actually live in the Santa Cruz Mountains, or just south of San Jose, which you can probably tell by the accent right straight away. And kind of my little side hobby is to grow vines and make some wine. So I'm very happy to have that message in a bottle sent to me saying that the grapes are ready and we're ready to go, and we've just completed another harvest, right? So very pleased to go do all that stuff. Sort of moving on from that, I run the global operation outside of China for EMQ. For those of you that are familiar with the MQTT protocol, there's kind of 2 or 3 companies that have been for the last, I'd say 8 years, have been taking this pretty seriously once IBM released the specifications to the open source. And one of those is EMQ, and we have grown considerably. We offer both open source products as well as enterprise level products, as well as a cloud version, a hosted cloud version of the products that we have. So I run the operations side, and delighted to be here to talk about that and tell you what we've seen here over the last couple of years, especially in the US, and how this thing has kind of grown considerably.
Excellent. Thank you for that, Dylan. And I think we'll have to request that you send perhaps not a message in a bottle, but maybe just some bottles of the wine you're growing. I'm very intrigued. Moving along to our final panelist, Ayanda, thank you for joining us. Kick it off with your selection of message protocol of choice, message in a bottle, carrier pigeon, or smoke signals, and then tell us a little bit about what you're working on now.
Yeah, I think I'll go with the pigeon as well, because yeah, my dad used to tag. We used to have some, yeah, I used to like just some pet pigeons, and they'll tag them and they'll go for months. And yeah, right before Christmas, you see them back with the same tag, and so reliable. So yeah, I'll probably go for that. And what I'm working on at the moment, okay, so basically I'm a principal engineer at 8x8, right? So we work on unified communication systems, and there's so many protocols that we have to deal with. And a lot of messaging protocols, right, which cross over to both instant messaging and machine-to-machine messaging as well. But on the RabbitMQ side, yeah, I've done a lot of work with Erlang Solutions, right, working with RabbitMQ, dealing with a lot of clients, doing a lot of customizations on the product, yeah, fixing a lot of yeah, issues, and yeah, doing a lot of consulting work there as well. So so yeah. Yeah, so yeah, anything design architecture around messaging, machine-to-machine messaging, as well as sorry, MQTT as well, right? But yeah, mostly MQP, right? So that is what I've been working on. Yeah.
Thank you for sharing. And I'll just remind our audience that you guys can feel free to submit questions through the Q&A. I know that our panelists would like to hear from you. But in the meantime, I'm actually going to kick off with a question for Paweł. You mentioned that the server has to handle a ton of traffic, that the traffic is unpredictable. So I'm curious, how do you handle all that traffic? How do you handle that scale? And is there anything about XMPP, I'm going to probably do that a lot, mix these up, XMPP, that helps you solve that problem?
Well, I have to start with that. We don't like have our own like installation of MongooseIM, that we have like our own clients. Instead, we are like MongooseIM is installed in many different places around the world, and there are many different companies using this product. So there are many different installations, and it's a very good question because each of them is unique. And in my opinion, like the only way to prepare yourself for this kind of traffic is to really figure out like what are the typical patterns, expected user patterns that will happen, and carefully and thoroughly load test the particular installation, because every single installation of MongooseIM has some special features that are implemented in so-called extension modules, and these features can be enabled or disabled and configured very differently. And some of them are like message archive and others. So you can have some of them enabled, some of them disabled. Some of the users can use this feature or that feature more extensively. So you need to know the users, you need to predict traffic a bit. Of course, this can be done when, even if you're a startup, then you can try a small scale. It's not a problem. So you can just observe what's going on and then try to load test this at higher scale and try to predict as how this will scale up. So yeah, the challenge is to really figure out like what's the expected load, and then after that it becomes easier, because after that it's MongooseIM can be load tested very easily. So then you can simply load test and see if it handles that amount of traffic. And also scaling up is MongooseIM can be scaled up vertically and horizontally. So it is possible then to scale up when the need arises.
I'm curious to hear from you, Ayanda. How does that match up to your own experiences working with clients who are leveraging RabbitMQ? I don't know. I've used RabbitMQ a lot, but I don't know that I've done a lot of load testing of it. Is that something that you recommend for RabbitMQ clients too?
Yeah. Yeah, I mean, load testing is quite a big part of, especially on the design phase, right? So when you're trying to do some sizing and, you know, just trying to, come up with a cost-effective spec for your machines and your hardware. So doing load testing is quite a big thing, because RabbitMQ is so flexible and it's so extensible as well that you can use up a ton of resources if you're not careful. If you don't plan out things properly. So yeah, and the good thing is that the RabbitMQ team, there's a lot of tooling that comes with the product as well. So load testing tools are literally readily available for you to use. So it's quite a big part of the initial design phase.
Yeah, that's definitely something that I've experienced a lot when working on the Beam, that it's sometimes too easy to scale up such that you start consuming even maybe more resources than the machine allows for. And that's always an interesting problem to have when your software is like so scalable and so concurrent that you run into the hardware limits.
Yeah.
So we've got RabbitMQ and we've got MongooseIM, which are both very scalable and allow for load testing. So why should I pick one or the other, or even EMQ? Maybe not so much sell me on your product, which I won't ask you to like pitch me your product or your company, but any particular reason to reach for one or the other of these messaging protocols in your guys' experience?
Yeah, I mean, they're for different use cases, right? So, I mean, we've seen cases where users have been trying to use RabbitMQ to build a instant messaging platform, and would immediately just direct them to the MongooseIM team. So yeah, it's all specific to what you want to do, right? So with RabbitMQ, I mean, I'll hand over to Paweł as well to share on the XMPP side. But with RabbitMQ, it's more on machine-to-machine interactions, right? And high performance of at the application-to-application level, right? So, but the moment you want to bring in the human factor, human interactions, that's where the primitives are already supported in the XMPP protocol, right? So that's where you want to go with MongooseIM or eJabberD and things like that. Yeah. And so yeah, Paweł, I don't know if you want to expand more on the XMPP side.
Yes, I can confirm what you just said, that XMPP is mostly oriented on human to human or human to machine sometimes communication. And you can even see that like the first clients of XMPP or Jabber at the time, it was even 20 years ago when it all started, the first client applications were end user applications from the very beginning. So you had a Jabber client where you can connect to and talk to your friends and things like that. So, and there is so much functionality built both into client libraries and the protocol itself that are focused on really on messaging between users. So you have means of sharing some files between users, of having contact lists So such thing as a contact list is like inherent to human communication. So yeah, and I can only add that I've dealt with installations where you would have MongooseIM as your core server for XMPP messaging. But for example, some of the messages were then delivered using RabbitMQ to some other system to do some other things, because it's not only messages like text messages, but also some special messages, system messages, let's say.
And I'd love to hear a little bit from you, Dylan, as well. Any particular reason to reach for EMQ specifically, but also for MQTT in general?
Well, let's just talk about the MQTT side of it first. And you know, certainly not here to bash the other protocols. You can look at I think Paweł, you know, nailed it. If you're looking at, you know, human to human environments, let's call it that way, where you're handling, you know, let's call it large files, right? I think XMPP is a very good solution for that. If on the other hand, you know, you've got the need for very fast communication, very lightweight payloads, then, you know, in my opinion, and this is why I'm, you know, with EMQ, we have a very, very scalable solution, right? That enables, you know, communication from a topic and subscription basis, you know, to be able to utilize the network more efficiently. Right. So again, end of the sales pitch from that perspective, where we're seeing it, where we're certainly seeing it taking a hold. I would say that, you know, if you asked me this question kind of 3 years ago, where did I see MQTT? Saw it, you know, in a lot of things like SCADA or SCADA, you know, type solutions. Certainly big use over in the, you know, the eastern part of the world. And it's kind of followed the sun, right? From a US perspective, I'd certainly put us in third place, you know, with respect to that. But boy, just in the last, you know, 18 months, the scalability side is the big thing. And, you know, to the question that was, well, not the question, the point that was made earlier, we're seeing an awful lot of designs now that are looking at large scale deployments. And that leads to, from a design perspective, doing all that load testing, looking at that scalability from an early stage onset. And, you know, if you're looking at Internet of Vehicles, if you're looking at big financial systems, you know, that or even video surveillance, right? An awful lot of video surveillance customers, not for the video content, but for the management of the health of the device that they're connecting to. So anybody that's deploying, you know, lots of devices that is looking for lightweight protocols, you know, we believe anyway, they're moving in that, you know, MQTT direction. It's certainly more of a flavor of a month than it was, I would say, 2 years ago, for sure.
You mentioned that with MQTT, you're able to use the network more efficiently, and that's one thing that helps with scaling. Could you expand a little bit on that? How is it that you're able to use the network more efficiently?
Well, again, just from the subscribe and topic perspective, when you're doing a almost like a one-to-one communication as opposed to a one-to-many broadcast, right? So if a specific information only needs to go to a certain set of devices, then you can control that through a subscription and topic basis. So therefore, just inherently, your network consumption is less, right? As opposed to having to send a message to, you know, the network that goes to all devices, right? So the latency will be less, and the use of the network just becomes inherently more efficient.
And Dylan, you also mentioned that you're seeing a growth of interest in MQTT in the past 18 months. I think it almost goes without saying that the past 18 months in the history of the world have been a very unique time, especially for technology. So I'm curious to hear from you, Ayanda and Paweł, as well. Have you seen any big changes in the technologies that you're using, or the interest in them, or the trends there in that time frame?
Yeah, I mean, I think in the last year, which I've been working with Erlang Solutions, RabbitMQ team. I think we actually got so busy with the RabbitMQ more than ever, and we saw such a surge in usage and adoption RabbitMQ as well. Most services were, going online, and that's the thing with RabbitMQ. I mean, it's on the application layer because it fits quite a lot of use cases around that area. So even things like working from home, things being facilitated around that. There's a lot of adoption of RabbitMQ in quite a lot of services, right? So financial, and things like I know we worked with even mortgage management systems that were built around RabbitMQ. So there was quite a huge adoption of Rabbit around that. Yeah.
Yeah, I think it's almost a question that doesn't need to be asked. It almost goes without saying that as the world has become more distributed, that our technological platforms are relying on messaging more than ever before. But we do have a question from one of our audience members. We've got a question from Matt, who would love to hear about what are some of the reasons someone would choose one of these messaging protocols instead of just OTP. Any of you guys want to take that one on?
I can start. So with I guess with MQP and using a messaging broker like RabbitMQ, there are cases where, for example, if you start scaling across multiple data centers, Erlang distribution protocol out of the box, there's some cases that you would have to handle manually as well. So in terms of reliability and consistency of data, right, you would need to probably build on existing protocols to guarantee that data is consistent, right? The moment you start spanning across, a wide area network. So, and some of these primitives are already handled in MQP, for instance, right? So, so MQP would basically guarantee things like, in the presence of an unstable network, right? You already have primitives that are built in the protocol to handle such cases and just guarantee that your data will be consistent. So that's one case where you'd incorporate both Erlang distribution and Erlang message processing with maybe on a local area network, right? So if you've got Mnesia, for example, running in a LAN, you can incorporate Erlang distribution there, and then across different data centers, then go for something like the MQP, right? So, I don't know on the MongooseIM EMQ side if that's the same case as well.
Yeah, I mean, I think you just nailed it. To be honest, it's exactly that, right? I just probably would add the efficiency, the reliability, and the scalability across, as you said, the multiple data center approach. We have a couple of clients that are implementing and moving across, 30 million devices, right? So, and that's on a worldwide basis, but that's across multiple data centers. And again, the efficiencies that we brought to the table, or our solution from a scalability perspective, certainly made it the protocol of choice with respect to that. Paweł, I don't know if you wanted to add any more onto that, but
I can only say that XMPP is like the completely different end of the spectrum than using just the Erlang distribution, and because XMPP is meant to connect mobile devices, for example, from users from around the world. So there are many millions of such devices, whereas Erlang distribution is best when you have a cluster of machines working closely together, and there's like a full mesh of connections, so it doesn't scale up to many devices. But actually, Erlang distribution is used very much in MongooseIM, because you have a mobile, let's say a mobile client that sends an XMPP message with some text inside, then it reaches MongooseIM cluster, and let's say that the recipient is connected to another node of that cluster. inside the Erlang cluster, you will have Erlang distribution protocol, relaying this message between nodes of MongooseIM, because MongooseIM works in a cluster of 3 nodes is what we recommend as minimum. And yeah, so you can have inside the cluster, you will have Erlang distribution and OTP used very heavily, but outside of that, you need some other protocol. You need, for example, XMPP.
Yeah, this really brings me to one of the questions that I was excited to ask you guys. Aside from distribution, and Pavel, I think you just spoke to this very well, what are some of the ways that working with these messaging protocols really benefits from leveraging the Beam? I think that everyone here is interested in Beam technologies.
Okay, I can start. So
Yeah.
I'd say that the Beam and Erlang OTP is really good at handling some unpredictable traffic, because it's not typical parallel processing where you have like something like single instruction, multiple data or things like that, but you have a lot of incoming messages from all over the world, let's say, into your system, and each of them has to be handled differently, because one is a text message, one is a request for message archive, one is something else. So, and inside MongooseIM cluster, Erlang is really best for sending lots of messages between many different processes without any special pattern that you know beforehand. And Erlang really does this efficiently. Messages are super lightweight, and they're sent between many processes that, for example, in case of MongooseIM, each connected user has its own process that processes the incoming messages. So I think the architecture of the Beam really matches up with this many open connections, and really sending messages between connected clients inside the Beam means simply sending messages between processes, which is the very primitive that is the main point of the Beam.
Dylan or Ayanda, anything to add to that?
I would love to. Unfortunately, I can't. I'm not that familiar with the Beam and the work that's been done. So yeah, I'm going to have to sit that one out. Apart from the fact AMQ obviously uses Erlang as its language of choice. So my assumptions are, just given what Pavel was just talking about, it's very similar from a lightweight perspective. But again, I can't add any more to that from a technology perspective.
Yeah, so on the RabbitMQ side, I think it's very similar to what Pavel has mentioned as well, where you've got each new connection that is being established. I guess on MongooseIM, it's from a user. Then on the RabbitMQ side, it's from another application. So each incoming connection basically spawns an isolated process, which will basically be the handler for all the MQP messages that are inbound, right? And then I think what makes the Beam probably the best technology of choice is, I mean, within RabbitMQ, you have, another thousands of processes that are spawned which have to interact with each other, right? And there are things like, on top of that, you have to handle cases like flow control, for instance, right? Which is defined, basically just for throttling on the client side as well. And if you drill down to how the processes handle things like flow control, you'll notice that it boils down to message passing, which has to be very fast and very efficient at a very low level. So I can't imagine how you would implement that with other technologies, right? But Erlang message passing makes that so seamless, and it appears so easy to implement. But yeah, it's actually quite a massive use case that you're actually dealing with. So yeah, so the Beam is really awesome for that.
Yeah, thank you for that. So we've heard from you guys on why it's so what we win, I guess I would say, what we win from building these messaging protocols on top of Beam. We have another question from Adolfo. Hey, Adolfo. I really like this question. I'm going to shout it out. So with these messaging protocols, we can use other programming languages, right? Like there's plenty of clients, let's say for RabbitMQ in a variety of languages. Should we still use a Beam language? Is there any benefit to using a Beam language as a client for interfacing with these messaging protocols? I mean,
Well,
I'll tell you my preference is yes, because I want to write everything in Elixir or Erlang, but any particular reason other than, I don't know, developer happiness?
Yeah, I guess on the RabbitMQ side, yeah, you've got tons of client libraries that you can use to interact on AMQP, and yeah, I wouldn't say there's a major advantage of using Erlang or Elixir, but one strong point that we've noticed is you can, if you know what you're doing, I mean, you can even interact at an Erlang message passing level, right, for some operations that you might want to bypass AMQP, for instance, right? So, and quite a lot of plugins in RabbitMQ actually are built on that concept. So you've got a plugin to handle, to handle MQTT, for example. So RabbitMQ handles MQTT, and and it's not a sales pitch to to override EMQ, but yeah, it does handle MQTT, and the way it does it is you enable the plugin, right? And internally, the Erlang client is used to basically interact with the core MQP side, right? So that's one advantage of using Erlang, right? Is that you can literally interact at that level, right? With RabbitMQ, but yeah, nothing else. I wouldn't say there's much more. Paweł?
Any thoughts, Paweł, on the benefits of choosing a Beam language for your client-side language as well?
Yeah, so actually for XMPP, it would be quite the opposite. So I would say do not use Erlang for your client applications. If you're working if it's a typical use case where you have mobile devices, because there are like no benefits for me of trying to use Erlang on an Android device or an iOS device, and there are already many ready-to-use client applications that you can use, like Smack, for example, to build your client applications. But and this is because in XMPP there is this clear distinction between clients that are usually end users connecting and communicating using very like lightweight devices, mobile devices, for example, and this big server that's handling all the traffic. But there are some exceptions. Sometimes you might have some, for example, external components that connect to your XMPP server, and then it might make sense to, in that components which are not typical clients, to use also a Beam language, probably because you can share some libraries, and of course, and also leverage maybe your experience that you already have with the Beam language on the server side, and for consistency, because if you have less technologies, it's easier to maintain, but it really depends on the case. I mean, for an XMPP server, I would definitely choose Erlang OTP. For clients, rather not.
Thank you for that. So we've got just 2 minutes left, and I have one more question for you guys, and maybe I'll start with Dylan. Pretty much all three of you have mentioned increased adoption, increased interest in the past year, 18 months. So I'd love to hear, what are some of the challenges that has brought?
Well, challenges is growth for sure as a company. EMQ has grown to, what are we now, 130 people, which is about another 60 in the last 12 months. one thing, as I'm talking to mostly people here in the US, if you're Erlang developers, you're considered gold dust right now. That's certainly something, just even with all of our clients, where they are definitely at a shortage of having Erlang experience on their teams. And we see it when we're talking with them, when we're looking at the scalability and running some tests at the beginning, when we're really early in the design phase, you can just tell, you bring our engineers into the room and theirs, and that expertise just isn't there right now. So definitely that's one of the challenges that we're seeing. I think that just from a market perspective, there is still, my personal perspective, there's still some confusion. And so I was loving the questions here about languages, hey, I'm a Java developer. Should I be using Java to do all this? It's way easier. Well, it's kind of not if you start looking at other issues, right? And so Erlang in that instance, could be seen as more efficient. But again, it's, you're into kind of that consumer of choice, right? It's, hey, you're up against, a lot of zealots who are very big, good Java developers, right? So introducing Erlang is sometimes a challenge there. Let's see what else. Just, the growth from the market, though, just the need for lightweight protocols and supporting, you look at the Internet of Vehicles is a great example of this, right? Whereas, we have a bunch of customers that Lucid Technologies just released first products rolled off the product line here just yesterday, the day before, right? Great example of a customer who've been using us, from very early stages of their design, but now we're seeing that much more prevalent use of MQTT inside the bigger car manufacturers as well, right? So just, example of just dealing with the scale of what where we've been working and how we've been working. Again, 18 months ago, 2 years ago, there was a lot of companies that were implementing, hey, we're looking at 1,000 concurrent connections, we're looking at 5,000. Most of the bigger companies we're talking to now is they're building, big IoT backplanes, which are, we need to handle at least 3 to 5 million. Can you guys handle our scaling? Can you guys handle our handling of our certificates, our security? And it's really, that's the kind of area that we're dealing in today.
Yeah, I'm not at all surprised to hear that. It's all about scale and it's all about growth. I think with that, actually, unfortunately, we're out of time, but I will encourage our attendees to continue this conversation in the community and messages features of Whova. I don't want to put you guys on the spot, Dylan, Ayanda, and Paweł, but I hope that if someone had a question they didn't have a chance to ask here, you would welcome hearing from them through Whova messages. And aside from that, thank you guys so much, Dylan, Ayanda, Paweł. It was absolutely wonderful having you. Really great conversation. Thank you to all our attendees. Thank you to the few folks who asked questions, and we'll see you around the conference.